Okay, this is number one. Two missiles were fired exactly at 12 noon. One landed when the hands, that's the minute hand and hour hand, of the clock were together between 3 p.m. and 4 p.m. The other landed when the hands, the minute and the hour hand, of the clock were together between 8 and 9 p.m. What was the total flying time of both missiles? All work must be shown, including the exact flight times of each missile. So I realize for a lot of students looking at that, they think it's an easy question. I'm not saying it's a difficult question, but I certainly would want to go through it and understand what's happening over here. All right. So there's two missiles being fired, and I say missiles. It's going up like this, and then it comes down and it lands somewhere. Right, and it's both occurring at 12 noon. Let's just talk about the first missile. All right, what does it do? It's up in the air, right? So two missiles, fired. This first guy, one landed. It says it landed between 3 and 4 p.m. So I know it landed between 3 and 4 p.m. So I know its flight time is somewhere between, if it left at 12, somewhere between 3 and 4. What they said, though, was something about the clock's hands, by the way. So let me point out what 3 p.m. would look like to me. You get something like this over here, all right? So that's what 3 p.m. looks like to me. And the hands of the clock, by the way. Now, of course, what they said was the minute hand would be on top of the hour hand. So the minute hand's advancing, right? The minute hand advances. So I want to talk about the minute hand first. The minute hand is advancing. But I want to point out the hour hand is a head start. But I want to talk about how long it takes the minute hand to complete a cycle. And the minute hand, it would do one rev, right? One rev. Let me see if I want to do this in hours or in minutes. So let me take a look. I can do it in hours. So he does one rev in 1 hour. Whoops, hour. That's the minute hand. I want to talk about the hour hand now. These are hands, by the way. Talk about the hour hand. It does one rev every 12 hours. Or much slower, by the way. Now, I want to point out, I'm kind of figuring out what time would this occur between 3 and 4 when they line up to each other. So I hope you realize that the minute hand, this is a rate times time problem. So its rate is over here. And by the way, what I mean by rate times time, the rate is in revolutions per hour, and the time would be an hour. So I'm going to say, how many hours? I have no idea. So it would be T times, and I'm going to certainly simplify this equation in a moment, over 1 hour. So again, I know it's between 3 and 4 p.m. T is the amount of time it takes between 3 and 4 p.m. But the hour hand's got a head start. Right? How much of a head start? Quarter of a revolution head start. So 1/4 rev. But the hour hand still moves, right? And he's still given, the time times, that's 1 rev over 12 hours. All right, I'm going to get rid of all those units, and you can, you understand that T is an hour, so the hours would cancel out, and you can divide both sides by revolutions. So you'd actually get a pretty simple equation. You'd get T equals T over 12 plus 1/4. And again, T is in hours. T is in hours. I'm going to multiply both sides by 12. You get 12T. That would be T plus 3. And then I'll take T from both sides. You get 11T equals 3. And then I'm going to divide both sides by 11, and you would get T equals 3/11. So I'm going to say the flight time for this first missile. This is the first missile, by the way. These are missiles, right? Is it's 3 hours and 3/11. So I'll put this over 3 and 3/11 of an hour. That's its flight time. Now you can convert this to minutes and seconds if you want, but I'm going to say 3 and 3/11 of an hour. Let's look at the other missile. The other missile, it's taken a lot longer to land, by the way. And so I'll put this over here. The other missile, I'm going to put this over here. Kind of goes up here. It's taken a lot longer to land. And the question is, when did it land? It landed. I got to go back and read. I can't remember, between 8 and 9 p.m. All right. So I know its flight time is, it's leaving at 12. It's between, it's 8 and some hours, right? But they said something about that. I want to look at the clock for that too. So at 8 o'clock, it's going to look like this over here. And this is always like, you say, I don't know what that means. That's at 8 o'clock, the minute hand's on the 12, and the hour hand is over here somewhere. All right? So it's really the same story, right? The hour hand has a head start. And what's the head start over there? And that's the part where a lot of students get confused with it. And I want to talk about it, the 8 p.m. mark, right? So let me just put a clock down for you. You have 12, you have a 6 over here, you have a 3 over here, you have a 9 over here, and you got numbers between them like 1 and 2, 4, 5, 7, 8. And I think you start to realize that, our clock is looking like this over here, all right? Question is, how much of a head start does it have? All right. Well, I'm looking at that, and I just wanted to talk about the number of minutes that it would take, so I want to get the revolutions out of it. And that's, 8 would be 40 minutes, right? So 40 minutes, but the complete revolution is going to be 60 minutes. I'm trying to get what the head start is, and that's going to be, what, 2/3, right? So it's really 2/3 of a head start. I'm really doing the same thing. Now, this guy might have been easier for me because it was just like a quarter head start, but this guy's got 2/3 of a head start. So it's really going to be the same thing. The minute hand's going to take, T hours to catch up. I just don't know what that is yet. And the hour hand's going at a rate of T times. That's 1/12. I'm really doing the same thing I did before, plus the head start, which is 2/3. All right, let's multiply both sides by 12. You get, 12T. It almost looks like the same exact thing, doesn't it? That equals T. 3 goes into 12 4 times, and 4 times 2 is 8. You get 11T, and this would be equal to 8, right? So T is going to equal 8 11s, and that's of an hour, by the way. This T is an hour. So what's this guy over here, this second missile? And again, we'll get back to their question in a moment. I'm just talking about my understanding of this thing. So it's going to be 8, and I just figured the number out, 8 11s of an hour. All right, that's how long it's going to take. All right, so the bottom line, I go back and read the question is what's the total flying time? All work must be shown. I pretty much put a lot of work down there, including exact flight times of each missile. And I've got that down over here. So the first missile, this is the exact flight time. Second missile, exact flight time. Let's add it together, though, the total time. So 3 plus 8 is 11, and 3 11s plus 8 11s would be 11 11s. So what do you get? 12 hours is total flight time. This is total flight. All right, we're done. Thank you.